problems for quadratics, all right? And we have two different types of application problems. One is this type right here, which is, they called it geometry and consecutive number problems. So the geometry part is area. You can write that above geometry, area. And then consecutive numbers. Does anyone know what the word consecutive means? Yes. One after the other. Okay, so area and consecutive numbers. Okay, and then after that, we have projectile motion. Okay, so those are the two types of problems we're doing today. We might do some today, some tomorrow. Okay, so we'll see how far we get, and then we'll decide what our homework is going to end up being. No need to worry, it will not be a horrible amount. Okay? All right, so the first problem says the width of a rectangle is 6 meters less than its length. How do we find the area of a rectangle? Length times width. Okay, so let's go ahead and write down length and width. And it says the width is 6 meters less than the length. So the length is the thing that they're basing the width off of, but we don't know what it is. So we're going to say the length is x. And the width is 6 meters less than that. So what should I write for width? X minus 6. Okay. And so if I wanted to write a formula for area, I would say area is length times width. But I actually know what my measurements are for length and width. What should I replace the L with? The L should be X, right? And then the W should be X minus 6. It doesn't really matter if you put them in backwards order. It's not a big deal. All right, and then they said the area is 112 meters squared. Okay, so we have this. So now, if we're going to solve this, what should we do? We're going to multiply the x. So we're going to have 112 equals x squared minus 6x. So at this point, we can recognize, oh, we have a quadratic. We got an x squared term, we got an x term, we got a number term. And when we solve quadratics, unless we are doing a completing the square process or solving by taking square roots, we like for it to equal 0. So would you guys like to solve by, we can't solve by taking square roots because we have a 6x there. So do you guys want to try to solve by factoring? Do you want to solve by completing the square? Or do you guys want to solve with the quadratic formula? It is up to you. You guys want to do completing the square? Okay. So we have x squared minus 6x. How do we do the completing the square process? So I'm going to leave my blank here. I'm going to say I've got the negative 6 down here. And then what do I do? Negative 3 and negative 3, okay. And what number goes on the top? 9. And if I put the 9 on the top right here, that means I've got a 9 right here. What do I have to do on the left side to keep the equation balanced? I have to put a 9 over there. And if I have a 112 and I add a 9 to it, what do I get? 121. So 121 equals, and I've got something squared. X minus 3, okay. So I've got to the point where I've done the completing the square process. At this point, I'm switching back from completing the square, now I'm solving. So now I'm going to do my order of operations backwards. So can I add or subtract? Can I multiply or divide? Is there an exponent I can get rid of? Getting inside those parentheses. So I can't add or subtract to the other side to get closer to x, because that 3 is inside the parentheses, it's protected. I can't multiply or divide to get to the x, so there has to be an exponent I can either introduce or get rid of. What do I need to do? Square root. Okay, and so when I square root, what do I get? Wait, am I killing a horse here or not killing? plus minus 11. I'm not killing a horsey today. Okay, and at this point, I'm getting inside the parentheses, and then I'm starting the process again. So when I get inside the parentheses, what should I do? Add the 3 over. So I get x equals positive or negative 11 plus 3. Okay? So x could be, what's positive 11 plus 3? 14. Or x could be negative 11 plus 3, negative 8. Now, does a length of a rectangle of negative 8 make sense? Okay, so that's a number that numerically we could solve for, but for the problem, we call it extraneous. It doesn't make sense for the problem, so we cross that answer out. Mathematically speaking, it's good. In the context of the problem, it is silly. So that answer is not going to work. So we're going to say the dimensions of the rectangle, the length is 14. The width is 14 minus 6, which is 8. The fact that it is the positive version of the answer we crossed out is a coincidence. We can't automatically assume that's going to be the case every time. That was a coincidence. All right, there are the 2 answers we have. Meters, thank you for that reminder. Meters. Because they are one dimension, it is the length of something. It's not an area, it's not a volume. The units are meters and not meters squared. All right, how do we feel about the problem? Pretty good? Okay. All right, let's go ahead and move on to a triangle. Yes, Nate. It didn't become an 8. The negative 8 was crossed out. We completely ignored it. We went back up here and we said 14 was our x value. And so then our width was 14 minus 6, which is where we got the positive 8 from. Yep. So those numbers being the same but opposite signs was a coincidence. They had nothing to do with each other. Okay. All right, let's go down and let's do a triangle question. So we have 2 triangle questions on the sheet. We have number 4, we have number 5. So number 4 sounds like it's just a regular triangle. Number 5 talks about a hypotenuse, so they're talking about a right triangle. Would you guys rather do number 4 or would you rather do number 5? 4? We're feeling number 4? 5? 4? 5? 5. 5, 4, 4, 5, 5, 4, 5, 5. Mine. No? You guys sound like seagulls from Finding Nemo. All right. It's not gonna matter, and I'll show you why. We'll draw a picture for both, and then I'll show you why it doesn't matter. Okay. So let's go ahead and draw this as just a regular triangle. And then for number 5, let's draw this as a triangle that's a right triangle. Oh, actually, maybe it does matter. Well, we can go ahead and do both if you guys feel better about that. Yeah, it actually probably does matter. Okay. Well, I was thinking that it was area either way, but it doesn't appear to be using the same formula, so it would probably be good for us to do both of them, actually. Okay, so for number 4, it says the base of a triangle is 7 less than twice its height. So I'm going to go ahead and just label this. We got our base, we've got our height, base and height, and they said the area. So our formula is area equals, and then what's the formula for area of a triangle? Okay, so we've got 2, we can say base times height divided by 2, that's how some people phrase it, and some people phrase it as area equals 1/2 times base times height. So you can think of it as a fraction problem, or you can think of it as a problem that just happens to have a fraction in front of it. Either way you think of it is fine, okay? Do you guys want to think of it as a problem where the whole thing is a fraction, or do you want to think of it as a problem that just has a fraction in front of it? The first one? Yes. Okay, so we're going to think of it this way. Okay. All right, so it says the base of the triangle is 7 less than twice the height. So since they said the base, they were saying the base is based off of the height. They're using the base in terms of the height. That means that the height is going to be the x. Just like before, they started describing the width, and they were describing the width based off the length, and that told us the length should be the x. This time they are describing the base from the height, which means the height is what should be the x. Does that make sense? Okay, so we're going to call the height x. And now it says the base of the triangle is 7 less than twice the height. So how do we write 7 less than twice the height? Is it x squared or is it 2x? 2x minus 7. Okay, so twice the height is 2 times the height. Okay, so they said the area is 102. So we're going to say area 102 equals base times height. So we're going to do 2x minus 7 base times height divided by 2. Base times height divided by 2. Are we comfortable with that? Okay. Now, I don't know about you guys, but I'm not a fan of that divide by 2 right now. How can we fix that? Multiply by 2. So we're going to undo the divide by 2 by multiplying by 2. So multiply by 2, that cancels it out. What is 2 times 102? 204. Okay? So we have 204 equals 2x minus 7 times x. Okay? And then what should we do with the x? We should multiply it. We should distribute it. So we get 204 equals 2x squared minus 7x. Okay, so we have a quadratic. Just a reminder, methods for solving are factor, taking square roots, quadratic formula, and completing the square. We know that taking square roots is not an option because of the 7x in there. So that takes out one of our options. So our options that we have left over are factoring, completing the square, and quadratic formula. You guys want to do completing the square again? No? Quadratic formula this time? Okay. So before we do quadratic formula, is it allowed to equal 204? No, it is not. What should it equal? 0. Okay, now the nice thing about quadratic formula in this situation is that we don't care, typically in story problems, we don't care about the simplified radical form, because if somebody says, what's the length of a triangle, nobody wants to hear root 53 or something like that, right? Nobody wants to hear something like that. They want to hear, give me a decimal answer. That makes more sense in the context of a story. So when we do a story problem like this, we only want the decimal answer. Okay, because decimal answers in a story problem are the ones that make the most sense to regular people. Does that make sense? Okay, so let's go ahead and subtract the 204 over. And so we know that our A is 2, our B is -7, our C is -204. So we have x equals, and what am I going to be writing for the quadratic formula? -7 plus minus. Divided by 2 times 2, okay. Okay, So I'm only going to do the part underneath the square root just to see what that is. I'm going to make sure to put parentheses around my -7 before I square it so I don't kill a baby otter. And so this is what I should be typing. So -7 squared minus 4 times 2 times -204. And what are you guys getting for this number? Marvelous. Okay. And this number is called the discriminant. Discriminant. Is that a perfect square? Does anyone know?
Yes.
That's a perfect square.
Yeah, it is.
Dang. Okay. 41.
Can you tell, like, since it has like two perfect squares in the number, it's 60 and 81.
Oh. I don't know if that's a way of telling or not. That's a good question. Okay, so what is 7 plus 41? 48. 48 divided by 4. 12. Okay, so we have x equals 12. Okay. And then we have 7 minus 41. Negative 34. Negative 34 divided by 4. Okay, and we don't even care about that one because it's negative and it doesn't make sense. Okay, so x equals positive 12 has to be the answer that we're looking at. Are we good so far? Okay, so what should we do with that positive 12? Plug it in and stuff. Okay, so our height is what? Our height is 12 centimeters, and then what's our base? Okay, so 2 times 12 is 24. 24 minus 7 is 17 centimeters. Okay.
It's fine if I did it at a certain height, or since it's new, you want me to do it at a certain height?
No, you can do it whichever way you want.
Okay, because I did like the complete square.
Yeah, how was that?
I also didn't do the thing with like the multiplication of the two.
Uh-huh.
It's the dividing. Because you get a fraction, but it's going to recalculate it.
It works okay?
Yeah.
Okay, that's fine. All right. All right, so I'm going to label this. They talk about hypotenuse, shorter leg, longer leg. So let's go ahead and label this. We're going to do hypotenuse, shorter leg. Now for longer leg, I'm going to do a cursive L so that it doesn't look like a 1. So hypotenuse, shorter leg, longer leg. What formula brings all of those together? Yeah, a squared plus b squared equals c squared. And what's the name of that formula? Pythagorean theorem. Okay, so using our letters, because we labeled them differently than A, B, and C. Using our letters, what would the formula be? Okay. So what I want you to do is take a moment and see if you guys can figure out what the S, the L, and the H should be. What should S, L, and H be? What should S, L, and H be? Maybe to give a hint to people who are struggling, which one should be the plane X? S. S should be the plane X because the other two are based off of the shorter side. Okay. It says the longer leg is 7 feet longer than the shorter leg. So what should I put for the long leg? Yes, Avery. X plus 7. The hypotenuse of the triangle is 1 foot more than twice the length of the shorter leg. What should I put for the hypotenuse? Macy. 2x plus 1. Okay. So now, using my formula, what should I do? Plug them in. Okay. Yeah, this one's going to be obnoxious because we're going to have to do what thing that is not our favorite thing to do. Starts with an F. Foil. We're going to have to foil. I'm wondering if this problem is going to end up being a good factoring problem, maybe? So you're going to have to foil this, and you're going to have to foil this, because it says squared, which means you have to write it twice and foil it. Yes, foil this and this. Otherwise, you kill a kitten. Please don't kill any kittens.
I'll be honest.
Okay, I'm gonna update you guys on the inner workings of my personal life. So there is a neighborhood cat that you guys are like, oh, it's about cats. There's a neighborhood cat. I call him Rico Suave because he sneaks into my house. It's very suave of him. He sneaks into my house and he eats all my cat food, and he's very chunky. He's like chunky cat, and I love him so much. He has the most interesting meow I've ever heard. Like, and sometimes he doesn't feel like using the pet door because it's a lot of energy. There's like 2 doors hanging down to save me from the weather. And so sometimes those 2 doors hanging down are just too much to push through. And so instead of pushing through it himself, he just sits outside and screams at me until I push the door open for him. And then he comes inside. And then instead of pushing the door open to go back outside, he pretends that he can't open it himself. And he waits for me to open it for him so he can go back outside. So as you can tell, he's quite the character. So I've decided that he should be mine. He's clearly adopted me. So I put the 2 cats that I own have bow ties on them. So I put a bow tie on him to stake my claim. But then you can't just claim a cat. You can't just be like, oh, this is my cat now. So I put a little note in his collar, the collar that I put on him that said, hey, is this anybody's cat? And then I did that on Saturday. And then on Sunday, the note was gone, but the collar was still there. And I was like, what does that mean? I don't know what that means. And I thought maybe, I don't know, maybe things got wild. Maybe he was like rolling around in the dirt or something and the note fell out. It's, yeah, the bow ties are usually attached by like pieces of elastic or something. So I wrote a new note this morning. But the thing is, because if you owned a cat, let's take a vote. If you owned a cat that was an outdoor cat and somebody else put a collar on it and you saw it, the first thing you would do is take the collar off. Am I right? Yeah, so I put the collar on Saturday. It is now Tuesday morning because he came over at 6 to steal my cat food again. So if you saw a collar on it, you'd take the collar off, right? So in theory, if he has owners, he hasn't seen them since Saturday, but he's seen me every day since then. He's my cat. He's my cat. I think we know that by now. He's my cat. He's my cat. So the next thing we're gonna, like, I put like a little cheapo bow tie on him that I have, which means that he's a very chunky cat with a very small bow tie on right now. It looks ridiculous, but I put another note on today just in case the other note fell off. I don't want to be offensive about this, but I will keep you guys updated on whether or not I have 2 or 3 cats, because we are working on the 3rd. You know how that goes. So. All right, I just want you guys to, I'll keep you updated. Why are you not invested in my cat story?
I am. I just want to know if I can just put my work on the other question.
Hold on, I'm distracted.
Okay.
Is this right? Is this what you guys got?
Yes.
Okay. So what have you guys done from here? Okay, so you brought everything over to this side. Negative 2x squared plus 10x plus 48 equals 0. Okay. Have we decided on a potential solution method? So we know for sure we cannot take square roots, right, because of the 10x. We can't do taking square roots. So our options are completing a square, quadratic formula, or factoring. Has anyone tried to factor? Is this a good factoring problem? This is a good. Okay, so you can do any of the other methods you want. Yeah. Yes. Yeah. Sure. Yeah. All right. So if we factor, what should we do first? Is this a slide divide problem? No. It's a GCF problem. Okay, so we're going to take out a -2, x squared minus 5x minus 24. Ooh, okay, yes, I'm seeing it. Okay. And then what do we do? There we go. Two numbers that multiply to -24 that add to -5, and the numbers are -8, +3. Okay. X minus 8, x plus 3. Okay. And what do we get for x? 8, -3. Does -3 work as an answer? No. Now, oh, the 2. Let's put the -2 right there. Now, does the -2 impact our answers? It does not. Okay. So the -3 cannot work because now it's possible that the -3, it's not that all negative answers don't work. It's that when you have an x as a plain side, that's what makes the negative answers not work. So if you ever run into a problem where it's like all the sides are like x plus 7, x plus 10, x plus 15, then a -3 would have been fine. Does that make sense? If we had x plus 7, x plus 10, x plus 15, a -3 would have been okay there. But because we have a side that is only x, that's why the -3 is not working. So -3 is not okay. Okay, so our short side is what? 8. Our long side is what? 15. And that's not our longest side, that's just the long leg. And then our hypotenuse is 2 times 8, which is 16 plus 1 is 17. And there's our 3 sides. Okay, so I think what we're going to do is I think we're just going to say only the front side of this, and we're going to deal with the consecutive numbers tomorrow so that we don't overwhelm this sheet. And now we're going to switch over to the projectile motion.
I think we did like, I remember doing projectile motion last year, and it did not work because she never taught us it, but then gave us the paper like, you don't have to do it. Actually, no, do it. And then I'm like, oh, but how? And she was like, oh, you'll be fine.
I mean, COVID was all sorts of craziness, but we're going to learn it right now. So let's go ahead and do this right now. So this sheet that says applications, homework, it's not going to be homework, it's going to be our notes, okay? So you guys have this in front of you, and then you have that one sheet that I handed per group that has a picture on it of the projectile motion. Okay. Okay. So this is it says quadratic keywords. This is the big picture perspective of how you find the different things they might ask for in a projectile motion problem. So projectile motion problems, they typically talk about launching something, launching a water balloon, launching a pumpkin, launching, I don't know, a bird. No, that's mean. Okay. No.
Launching a firework?
No, we don't launch cats. We are nice to cats. Okay.
How about launching an egg?
There you go. So we're gonna walk through the way that they would phrase different questions, and when they phrase those questions, what are they really asking for? So in here, you can see this is the flight pattern of the thing that is launched. So this would be kind of like the starting point. It launches, it goes up into the air, it reaches its highest point, and then it goes down, 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 splash. And this is where it hits the ground, okay? So This y-intercept is how high it launches off the ground. Where did the object start? Does that make sense? So typically, things are not launched straight off the ground. They're usually on a platform of some sort. All right, it would be very hard to launch something like flat on the ground, because you usually, like if you're doing like a water balloon launch or something, you have to like stand there and like pull it down, and usually you're not actually pulling it all the way to the ground. You're usually at least a few inches above the ground. So how high off the ground did the object start? Just a reminder, at the y-intercept, what is the x value? X equals 0. Okay, so just a little reminder there. Somebody at the table put x equals 0 on the sheet right there. All right, now the vertex, they're going to ask you questions. If they want the x value, they're going to ask you a question like, when did the object reach its maximum height? If they want the y value, they're going to ask you a question like, how high did the object get? Okay, just a reminder, this is something you can add to your sheet. If you want the x coordinate, you're going to do x equals negative b over 2a. Just a reminder, x equals negative b over 2a. How do you find the y coordinate? You plug in whatever number you got for x, okay? You'd find x, negative b over 2a, you'd plug it in, you'd find your y coordinate, okay? If they ask you a question, how high is the object after a certain number of seconds, you're going to plug in the given number of seconds into the graph's equation. So if they say, how high is the object after 2 seconds, then you're going to say x equals 2, and you're going to plug in x equals 2. If they say, how high is the water balloon after 5 seconds, you're going to say x equals 5. You're going to plug in 5. Does that make sense? Yep, it'll always be just that number. Just plug in that number, okay? Down here, so we're going to have an x-intercept that you're always going to throw out. It's going to be this one over here. It's going to be an x-intercept that is a negative number, and it's kind of like those x-intercepts that we've been throwing out the whole time on the worksheet we just did. You have x-intercepts that don't make sense for the problem, so we're going to ignore them. These x-intercepts over here are going to have questions like, when did the object hit the ground? Or how long was it in the air? Or when did it make a splat sound? I don't know, something like that. Those are going to be your positive x-intercepts, okay? How are we going to find those values? What are our different ways of finding those? We just talked about it a bunch of times. How do we find these? What's our way of solving for these? They're x-intercepts. How do we find the x-intercepts? So I'll give you one. Factoring is one. What's another one? Quadratic formula. What's another one? Completing the square. And then taking square roots. So all of those different methods will do it. It's just whichever one feels the most comfortable for the problem. Quadratic formula is going to be the one that works the most often. And today the quadratic formula, hi. Oh, hello. And today the quadratic formula is going to be less painful because all we're doing with it is finding decimal answers. We are not simplifying square roots. Does that make sense? So quadratic formula today is not so bad. All right. So we're going to keep this. This is why there's only one sheet per group. We're just going to keep this as our big picture perspective so that if they ask a question, we know, okay, this is exactly what we're trying to find today. Does that make sense? Okay. So let's start going through these questions. All right, the first one, it says a model rocket launched from the roof of a building. Its flight path is modeled by this quadratic, where h is the height of the rocket above the ground in meters, and t is the time after after the launch in seconds. What is the rocket's maximum height? So when they say, what is the rocket's maximum height, what part of the parabola are we looking for? We are looking for the vertex. When it says, what is the maximum height, are we looking for the x coordinate of the vertex or the y coordinate of the vertex? Wait. Maximum height, we are looking for the y coordinate of the vertex. Okay, so let's go ahead and take this. We at least need the x coordinate first, right? So we're going to say x equals negative b over 2a. We do need that first so that we can find the y coordinate. And so we're going to plug in what to our calculator? Okay, negative 30 over 2 times negative 5. And so what number is that? 3. Okay, so now I'm going to take my calculator. I'm going to put the 3 in for x. It's a t technically, but I'm going to go ahead and use x just because that's what I'm used to, and my calculator will handle it just fine. And I'm going to do negative 5x squared plus 30x plus 10. And then what do I get? Okay, so we get y equals 55. Okay, so now I'm going to say, did they say it's in meters? So now I'm going to say 55 meters, put a box around it. That's my answer. Okay. Uh-huh. Uh-huh. Okay. And so now it says, when did the rocket reach the maximum height? 3. Yep, the maximum height is always the vertex. 3 seconds. After the launch time in seconds, yep. All right. Okay, now it says, when does the rocket hit the ground? When does the rocket hit the ground? So, when does the rocket hit the ground? We're looking for an x-intercept. We can factor, we can quadratic formula, we can complete the square, we can take square roots, except when I look at the formula, I can see a 30t, which means I cannot take square roots. So my options are factor, quadratic formula, complete the square. Quadratic formula? Okay, so let's write out the quadratic formula. We have x equals, how should I write it out? Yeah.
Wait, we only have one.
I can make more copies.
This is very helpful. Sorry, Savannah. Don't say that, Sophie. I'm never sorry to Savannah. I think Savannah's mad. Because Savannah's literally so rude. She's so mean. Yeah, Savannah's like the meanest person in school. Like, awful. Like, she's, oh.
What are you guys getting for your discriminant? That's your number underneath the square root. What are you guys getting? Okay, I do not think that's a perfect square. Is that a perfect square?
Absolutely not.
Okay, so I'm just going to remind you guys how we can plug this in all at once. So here's the way we're going to do it. We're going to hit alpha y equals. So alpha is your green button. We're going to hit alpha y equals. Alpha y equals, and remember, when we do this, we're going to get two answers. We're probably going to get a negative x-intercept and a positive x-intercept, and we're going to ignore the negative one because it's not the answer we're looking for, okay? It's called an extraneous solution, so we're only going to find the positive answer. It is a good idea to write both answers down to show that mathematically you found both of them, okay? So I'm going to do alpha y equals, I'm going to use option number 1. Okay, that allows you to plug this in as a numerator over a denominator. That's what that means. So option number 1, and then I'm going to type in negative 30 plus square root 1100 over negative 10. Okay, there's our negative answer. I'm going to write it down. Is this the right answer? This is not the right answer. I'm doing my 3 decimal places. Okay. Now I'm gonna, so to type this in, you hit alpha, alpha y equals number 1. Negative 30 minus square root. Yep, you can do that. So the answer for when does the rocket hit the ground is what? So I'm going to say 6.317 seconds. Marvelous. Alrighty. Let's try the next one. Yes. Your calculator needs an update. I will do that for you. Not right now. I will do it in a few minutes. So for now, look on with Joey, and then I will do it once we start working in class. I will. Nate. Yes. All right. Next problem. All right. It says, how high is the balloon after 1 second? So this is asking a question that says how high. So if it's asking the question how high, that's a meters question. That's a Y value. When it says after 1 second, they're giving you an X value to plug in. Okay? So we're going to take the X value that we want to plug in. We're going to do 1. We're going to store it as X. And then we're going to go ahead and type that into the equation. All right, and what are we getting?
24.5.
Okay, so y equals 24.5. And so our answer is what? 24.5 meters. 1 comma 24.5 is the point. She was not wrong. She was just saying the coordinates of the point. And then in the context of the problem, the answer is 24.5 meters. Okay, this says find the vertex of the parabola and write a complete sentence interpreting what the vertex of the parabola means in the context of the problem. All right, you guys, stretch out your fingers. We're about to write a whole sentence in math class. Oh, stretch them, stretch them, stretch them out, stretch them out, stretch them, stretch them, stretch them. All right, how do we find the vertex? Okay, x equals negative b over 2a, which is, what do I write? Negative. Okay, so this x value is not going to be very nice. Negative 27 divided by, now when you type this, if you have an older calculator, you're going to have to put this bottom part in parentheses, 2 times negative 4.9. If you have the newer calculators, you're going to do alpha y equals, and you're going to type this in like a fraction. Negative 27 divided by 2 times negative 4.9. See how you guys have that long decimal? This is what we're going to store as x. So when you still have this whole big thing on your screen, everyone see this whole big thing on your screen? This is when you're going to hit store as x. Okay? And instead of the number storing as x, it's going to say answer stores as x. Does everyone see that? Okay, now I'm going to press enter, and it just pops that number up again. Because all it's doing is it's taking the previous thing we typed in and it's storing that. Okay, so now we can go ahead and type that into the equation.
Nobody was talking to you. Sorry. I think it's supposed to stop talking.
Okay. Is this the vertex that you got?
Yes.
Yes. Did we get all our decimals right? We did? Yes? Did we get our decimals right? We should have if we stored it. 39.594. Oh, yes, yes. Yes. So let's use our sheets and let's interpret this problem. How do we interpret this vertex? So we're going to say, but we're not going to say the vertex is the maximum height. We're going to actually interpret these numbers in context. So what should we say? So we're going to say the water balloon what else am I going to say? Reaches a maximum height of 39.594 meters after 2.755 seconds. All right. How do your brains feel? They feeling brainy? They're feeling Englishy? Now, I need you guys, okay, stretch out your fingers. Get them stretched. Get them stretched. Okay, in Math 3, we do this again. We do nothing by hand. When we do this in Math 3, we do not do the quadratic formula. We do not do the vertex. We do not do anything by hand. We do it all in the calculator. And I make my students write a sentence for every single answer. Woo! 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 Yeah, you're going to do it next semester. It's going to be a good time. Woo, woo, woo. All right. Next problem. All right. When will the balloon hit the ground? What do we do to find when the balloon will hit the ground? What method are we going to use? We're going to use the quadratic formula or factoring or completing the square. Probably not taking square roots because we keep having that x value in there. Are we pretty solid on using just the quadratic formula for these problems? Yeah, okay. So we're going to do x equals, and then what should I write? Negative 27 plus or minus 27 squared. And then divided by 2 times a. Well, this answer is definitely a decimal. Okay, is this what you guys got when you were doing your quadratic formula?
Yes.
So 27 squared, I'm not done yet, that's just my discriminant, so I did 27 squared minus 4 times negative 4.9 times 2.4, there's my discriminant, my number underneath the square root sign. Okay, so now I'm ready to type the whole thing in, so I got my alpha y equals. So I got negative 27 plus the square root of 7076.04. I have a typo in there. 04. Oops. 04 divided by negative 9.8. Okay. Are we typing it? The final reveal. And everybody should be typing it because as I've been grading quizzes, it's the quadratic formula decimals on the first quiz at least that a lot of people were getting wrong. I'm not going to call out names.
Savannah, Alex, Sophia.
Okay, that's our negative answer, so this one is not going to be it.
Do we have to write a sentence for this one again?
Nope.
Oh. Oh my god,
That's what I'm saying.
Woo! All right, did we get it?
Yes.
We got it?
It's from her like very unsheltered
Marvelous.
childhood. Like I am really unsheltered.
Yeah.
Very.
Yeah.
Okay, how are we feeling? How are we feeling about these? Good? Our brains are okay? Okay. So the plan for the last 25 minutes is a scavenger hunt. Ooh. A scavenger hunt? Okay, what I want you to do is look over the rest of these questions and see if you can find one that like feels uncomfortable or any of these questions like, oh, I could not do that. What do you guys think?
I should do the other one that has decimals. Yeah. Any ones that have decimals or
I want to say the ones with the scavenger hunt were kind of nice. You guys want to do number 3? Yes? Okay.
I want to know what size I want.
If the weight reaches 15 feet, you win a prize. You can just double check and see the maximum height and see if it's 15 feet. You want to do number 3 because it has decimals? Okay. All right. Number 3. Okay. How do we do a question like this?
you
Plug in 1.4. Okay, so we're going to say, it says how high, that means we're finding a y value. It says after 1.4 seconds, that's an x value of 1.4. Okay, so we're going to take our calculators. We're going to do 1.4, put that as x.
Guys, your deepest voices. I want to see you show that. Sorry, I'm impressed. Wait, I got y equals 21.
I got y equals 25.696.
Yeah.
I got 2.
What's so good together? I did get that answer, and you messed up my decimal point.
Did you get 28.4?
No.
Oh no. Wait, why?
Alex, you silly bum.
Do you have a typo?
We literally did it right. I don't understand.
Did you store 1.4 as x?
I didn't do it.
There you go. Okay. Are we good with the first one? All right. Now, the next question is kind of interesting because it says, does the ball ever reach a height of 33 meters? I'm going to go ahead and write the question. So we're going to say h equals negative 4.9 t squared plus 24.5 t plus 1. Okay. So when it says, does the ball ever reach a height of 33 meters, is that an X value or a Y value? That's a Y. Okay, so we're going to, instead of plugging something in for X, we're going to plug this in for Y. So we're going to say 33 equals negative 4.9. That's a great idea. Let's do that instead. Okay. How do I find the vertex? Equals negative 24.5 over 2 times negative 4.9. So this is going to be one of those ones where the x-coordinate of the vertex is not very nice, and we're going to have to store that whole number. Oh, is it nice? Oh, okay. Oh, okay, okay. So we're going to store that as x, and then plug it into the equation. All right, and then what are you guys getting for your y-coordinate? Okay, so if the vertex is 2.5, 31.625, then does the ball ever reach a height of 33 meters?
No.
No.
It would be close to it, but not exactly.
And how do you know? Yeah, that's higher than the highest that's higher than the max height. So no, 33 meters is higher than the max height of 31.625 meters. Okay. When does the ball hit the ground? How are we going to find that? Quadratic formula. Are you feeling like you're getting better at the quadratic formula today? You have no other option. You have to. It's a required thing for today. We're over and over until you are good at it. It's good. All right, so when we write out the quadratic formula, what should we be writing? Divided by.
Go. Wait, you put 24 instead of 24. Misses. That's actually miss right. Oh, miss. I mean, miss right.
There's no need to yell at my mom. Goodness.
Yeah, why are you bringing monsters to